So this module will be talking about fractions divided by fractions. So what will you be learning today? We're going to be working from your packet, pages 47 to 57. This is the dividing fractions packet. And at the end of the packet, you will be able to identify the parts of a division equation, divide fractions by fractions, divide whole numbers by fractions, divide fractions by whole numbers, divide with mixed numbers. You'll be able to find a number when a fraction of it is given, and finally you'll be able to solve word problems with division of fractions. So let's get started with a few notes before we tackle the packet today. So notice that the parts of a division equation have names. So 15 divided by 3 equals 5. 15 is called the dividend. That is the number that is being divided. 3 is called the divisor, and that is the number that divides into the dividend. And finally, 5 is the quotient or the answer to the problem. You may see it written also in a form of long division like this. So if this was going to be written as long division, where would you put the 15? Exactly, you would put the 15 on the inside. That is your dividend. That's the number being divided by something else. You would put your 3 here, your divisor. That's the number that is dividing into the dividend. And your answer is your quotient, and that's going to go on top. You may see it like that. I want you to also notice something. If you have 15 divided by 3 equals 5, it's the same as multiplying 15 by the reciprocal. So what do I mean by the reciprocal? So here is the 3 right here. So that I could say is really technically 3 over 1. Wouldn't you say that 3 over 1 is the same as 3, because 3 divided by 1 is just 3. So the reciprocal of 3 over 1 is 1 on top, 3 on the bottom. The reciprocal is just flipping the fraction, taking the top number and putting it on the bottom, and the bottom number and putting it on the top. So for instance, if you had the number 3/4, the reciprocal of 3/4 would be 4 on top and 3 on the bottom, so 4/3. The reciprocal will be important in today's packet. So for instance, down here, as I was explaining, multiplying 15 by the reciprocal is the same as dividing 15 by 3. So 15 times 1/3, in our case here, 1/3 is the reciprocal of 3, right? 15 divided by 3. Now 15 times 1/3 will also give you 5. So that's how we're going to be working our division problems today. And notice as well, let me clear this, the answer will be larger than either fraction when dividing a fraction by a fraction, or when dividing a whole number by a fraction. Now you ask yourself, well, why is that? Well, if you think about it, when you're dividing by a fraction, you're dividing the first number into many smaller parts. And the smaller the part is, the more parts you need, right? So the bigger the number. So think about if you were dividing a 12 inches by let's say 1 foot. Divide 1 foot by 12 inches. Each inch is a certain size, right? But if you were to divide that 1 foot into half inches, you're going to have more half inches in that 12 foot than you are going to have inches. And if you're going to divide it into 1/4 inches, you're going to have even more. So that's why your answer is going to be bigger. You're going to have more parts. So here's the rule that we're going to be using on our packet today. When dividing, use the rule keep, change, flip. So for example, if I am given 1/4 divided by, let's say, 1/2. What I'm going to do is I'm going to keep the first fraction as 1/4. I'm going to change the sign from division to multiplying. And then I'm going to flip or use the reciprocal of the second fraction. So 1/2, the reciprocal would become 2 over 1. Because remember, dividing is the same as multiplying by the reciprocal. So then I would solve it just like I do with multiplication. 1/4 times 2 over 1 is going to give me 2/4, or If I was to reduce it, that would give me 1/2. So 1/4 divided by 1/2 is 1/2. Okay, so let's go and give the packet a try and see how this works. So here's your packet, dividing fractions by fractions. The first page is going to explain what I was just explaining about the dividend divisor and the quotient, and what you're really doing when you're dividing a fraction by a fraction, and how you'll end up with more parts the smaller the parts are. So now let's take a look at page 48 and we'll just try some problems out. So let's look at the first problem here, right here. Oops, let me just clear that, and I wanted a circle. So 3/7 divided by 2/5. So what you're going to be doing is we're going to keep the rule. Let me just put the rule up here. Keep, change, flip. So we're going to keep the first fraction. 3/7 is going to stay 3/7. We are going to change the sign from division to multiplication. And we are going to flip the second fraction. So that means take the reciprocal. So we're going to put the 5 on top. And we're going to put the 2 on the bottom. I don't see anything that's going to cancel. So I'm going to just multiply across the top. 3 times 5 is 15. And across the bottom, 7 times 2 is 14. So now I have 15/14. Now that's an improper fraction, so I don't want to leave it like that. So you're going to notice that with these, a lot of times you're going to have to do a little bit more after you get to your answer here. So we're going to make a division sign. And the top number is your dividend. That's going to go into the inside of your division sign symbol house thing. And the 14 is your divisor. That's going to go on the outside. And your answer, your quotient, is going on the top. So you ask yourself, how many 14s go into 15? 1. 14 times 1 is 14. 15 minus 14 is 1. I'm going to take the 1 and I'm going to bring it up to the top. That's my remainder. That's going to become the numerator. And the denominator is going to be 14. So 1 and 1/14 is my final answer. So we can put that in there. I can write that in here. 1 and 1/14 right here. So that is 3/7 divided by 2/5. Let's give another one a try. Let's try the one on the end here, right here. So if you want to pause the video and try it first and then check back and see if you got it right. We're going to keep going. So this one is keep 7/15 the way it was. Change the sign from division to multiplication and flip the second fraction. And by the way, you never want to flip the first fraction. Don't get confused by that, because if you start doing that, all of them are going to be wrong. So you want to make sure you only flip the second fraction. So now I see something that will cancel. So I'm going to go ahead and cancel ahead of time. I see that 5 will go into 15 3 times. And I see that 5 will go into itself once. So now when I multiply across the top, I've got 7 times 1, or 7. And on the bottom, I've got 3 times 4, or 12. And this one is good just the way it is, because I have an odd number on top and even on the bottom. This is in lowest terms. I don't have to do any division. So 7/12 is the answer to that one. Let's go on and try a few harder ones. Let's get a little bit harder here. Let's go down to row 6 and give a couple of those a try. Let's try this one right here. 12/19 divided by 18/38. So if I was going to do that, I'm going to keep following my rule. So let me put the rule back here. Keep, change, flip. So I'm going to keep the first fraction. 12/19 is going to stay 12/19. I'm going to change the sign from division to multiplication. And then I'm going to flip the second fraction. 38 is going to go on the top, and 18 is going to go on the bottom. I could go ahead and multiply across the top and across the bottom if I wanted, but I noticed that I can cancel, so I'm going to do that. Helps me later not to have such big numbers. So I know that 19 times 2 is 38. So I'm going to put 38 divided by 19 is going to be 2. 19 divided by itself is going to be 1. And I know that a 3 will go into 12 and it will go into 18. I also know that a 2 would work, but a 3 is a little bigger, so I can get my numbers down a little farther. 12 divided by 3 is going to give me 4, and 18 divided by 3 is going to give me 6, and I actually could have taken a bigger number, right? I could have taken 6. So I'm going to do it again. 4 divided by 2 is 2, and 6 divided by 2 is 3. So I actually could have taken 6 initially. But that's okay. If you don't notice that right away, you just keep doing it until you can't divide any further. And now I can go ahead and multiply across the top. I have a 2 times a 2, that's 4. And across the bottom, I have a 1 times a 3 is a 3. And I notice now I have an extra step because 4/3 is not how I want to leave it. So I'm going to divide. The 4 goes where? On the inside or the outside of my house? Yep, on the inside. And the 3 goes on the outside. 4 divided by 3 is 1. 3 times 1 is 3. 4 minus 3 is 1. I'm going to bring the 1 up here. It's going to become the numerator of my fraction, and the denominator is going to be the thirds, or 3. So the answer to that one is 1 1/3. Okay, let's move on to a little bit different here, dividing whole numbers by fractions. So you can go ahead and read that on your own time. Go ahead and see some examples in that. We're going to go right on and try number 1 on page 50. This is row number 1, problem number 1. So now we're going to be dividing a whole number by a fraction. So we have 12 divided by 2/5. Well, it's nothing much different except that we first have to get the 12 into fraction form. So we're going to write 12 over 1. Because isn't 12 over 1 really 12? Any whole number can be written over 1. And we're going to divide that by 2/5. Okay, and now we can do our keep, change, flip, and I'm going to make a little bit of white space here so I can continue my division thing here. Okay, so now I'm going to keep the first fraction as 12 over 1. I'm going to change the division to multiplying, and I'm going to flip the 2/5 to 5 over 2. I'm going to look now and see if there's anything I can cancel. I can cancel the 2 and the 12. So 12 divided by 2 is 6. 2 divided by itself is 1. And now I can multiply across the top and across the bottom, and I get 6 times 5 is 30. This one will turn out nice and neat for us. And on the bottom, 1 times 1 is 1. So my final answer then is, just 30. So 30 over 1 is really 30. So that ended up being a whole number. So notice how the whole number is bigger than the 12 and bigger than the 2/5, because you're dividing 12 into 2/5 parts. So you need 30 parts that are 2/5 of the size, so to speak. Okay, let's try a little bit harder. Let's go down to row 6 and give some of these a try. Let's try this one right here. A little bit of white space here for us. Didn't seem to work. Let's try that again. There we go. Okay, so we have 56. That is going to be our first number, and we're going to change it to 56 over 1, and that's divided by 24 over 25, and we do the keep, change, flip. So we're going to keep the first fraction as 56 over 1. 56 over 1. We're going to change the sign to times or multiplication. we're going to flip the second fraction. So the 25 is going to go on the top, and on the bottom is going to be 24. Now I know that there's a number that will divide into 56 and 24. I'm noticing that it's at least an 8. 7 times 8 is 56, and 24 divided by 8 is 3. So that is as far as I can divide or cancel. And now I have 7 times 25 on the top. So that's going to be 175. Make sure that that's right. 5 times 7 is 35. Carry the 3. 14, 15, 16. Yes, 175. And on the bottom, I get 1 times 3 or 3. Still not done. I have an improper fraction, so I'm going to use my division. And we're going to put long division up here. We're going to put what number on the inside? 175, top number on the inside, and on the outside is going to go the 3, and we are going to find the quotient. 3 won't go into 1, but 3 will go into 17 2 times, not 2 times, 3 times 6 is 18, 3 times 5, it'll go in there 5 times without going over. 3 times 5 is 15, so 17 minus 15 is 2. Bring down the 5. How many 3's go into 25? Well, 3 times 8 is 24. 3 times 9 is 27. That's over. So 3 times 8 is 24. Then I subtract 25 minus 24, and that gives me 1. So that's going to come up here, and that's going to become the numerator of my fraction, and the 3 is going to become the denominator. So the answer to this problem then is 58 1/3, and I could probably just circle that right over here. 58 1/3 is the answer to that. Okay, ready to move on? We're going to get a little bit harder and a little bit different. Dividing fractions by whole numbers. So first what we just did is we divided a whole number by a fraction. Now we're going to switch it around and start with the fraction. The second number is the whole number. So let's look at that. Let's go down to some problems on page 52. Look at the first one. We'll circle that. 4/5 divided by 4. Notice how the whole number is coming second this time. So what we're going to be doing, we're going to make some white space for us. And we are going to rewrite it as 4/5 divided by, what do we do with the 4? 4 over 1. Okay, now we use our keep, change, flip, same thing we've been doing. 4/5 change to times and flip the second fraction. So the 1's going on top, the 4 is going to go on the bottom. I notice that there's something I can cancel. The 4's will cancel into 1's because 4 divided by 4 is 1. 4 divided by 4 is 1 on the bottom. And then I am going to multiply across the top. I'm going to have 1 times 1 or 1. And across the bottom, I'm going to have 5 times 1 or 5. 1/5 is my answer. So that is the answer, and I'll circle that. So the first one, the answer is 1/5. So 4/5 divided by 4 is 1/5. Okay, let's look down a little bit of a ways here. Let's go down to row 6. Let's do the second one here, right here. So we have 15/16 divided by 45. So let's write that out. So we're going to keep the first fraction the way it is. We're going to change the sign to multiplication, and we're going to use the reciprocal of the second fraction. Well, we know the second fraction is really 45 over 1. So the reciprocal is going to be 1 on top and 45 on the bottom. And there is some canceling I can do. I probably can cancel by 15s. So 3 15s will go into 45. So 45 divided by 15 is going to give me 3. And 15 divided by itself is going to give me 1. Now I can multiply across the top. I get 1 times 1 is 1. And 16 times 3. 3 times 6 is 18. Carry the 1. 48. So 1/48 is the answer for that. Okay, we're doing okay? All right, good. That's clear, and let's move down a little bit further. Dividing with mixed numbers. So let's try a couple here. Let's go up to dividing and reducing. So we're going to try the first one. 1 1/2 divided by 3/4. Just a few extra steps. And you probably already figured out what they are because they're just like they were for the multiplying packet. The division and multiplication of fractions is very, very, very similar. So 1 1/2, we're going to rewrite 1 1/2 as an improper fraction. Remember, it's whole number times the bottom plus the top. So 1 times 2 plus 1, it's 2 plus 1 is 3. So this top number, the first fraction is going to become 3/2. Top number is 3, divided by, and I'm just going to keep doing it one step at a time here at the moment, divided by 3/4. Okay. Now that I have that step done, now I am going to keep change flip. I'm going to keep my first fraction as 3/2. I am going to multiply, change my sign, and I'm going to flip or use the reciprocal of 3/4, which is now 4/3. And now I am almost done. I can cancel some things. I can cancel the 3's. That becomes a 1. And that becomes a 1. And I can also cancel the 4 into the 2. The 2 into the 4. 4 divided by 2 is 2. 2 divided by itself is 1. And my answer is actually very easy now. I have 1 times 2 on top and 1 times 1 on the bottom. So 2/1 is the same as 2. So that one, the answer is 2. Okay, let's go ahead and clear that. Move down to a few other ones here. Let's go to lots and lots here. Let's try this one here. You can get lots of good practice. So let's do that one. Let's make a little bit of a white space here for us. Okay, so we have 4 3/8 divided by 1 9/16. So we're going to change 4 3/8 to an improper fraction. So whole number 4 times the bottom 8. 4 times 8, 32, plus the top, 33, 34, 35/8. Okay, so this becomes 35/8 divided by, we do the same thing for the second fraction in mixed number, I should say. Whole number times the bottom, 16, plus the top 9, 25. And the bottom number is 16, that stays the same. Okay, now we do our keep change flip. Keep the first fraction, 35/8. 35/8. Change the sign to multiplication and flip the second fraction. 16 becomes the top number. 25 becomes the bottom number. I can see some canceling that I'm able to do, so let's go ahead and do that. So we can take 5 into 35. 5 times 7 is 35. We can take 5 into 25 because 5 times 5 is 25. 8 will go into 16 twice. 8 will go into itself once. So now I multiply across the top, and I get 7 times 2, 14, and I get the bottom of 1 times 5, or 5. Improper fraction, I have to use division to make it a mixed number. So I'm going to put that there. What number goes on the inside? 14. What number goes on the outside? 5. No other choices either. How many 5s go into 14? 2. 2 times 5 is 10. subtract. 14 minus 10 is 4. The 4 becomes the top of my numerator of my fraction, 4 fifths. So the answer to that problem is 2 and 4 fifths. Okay, let's clear our drawings. And let's move on, see what's next. Finding a number when a fraction of it is given. Okay, this is slightly different, but not too bad. So if you want to look, for example, right up here for the steps, let's take a look at those for just a moment here and see an example of this right here. So move that a little bit over so it's not blocking our numbers. There. Okay, so 1/2 of what number is 12? So we're going to write 12 as an improper fraction as 12 over 1. And then we are going to divide it by 1/2. So that's the same as keeping 12 over 1 and timesing it by the reciprocal of 2 over 1. We get 24. So think about it logically. Half of what number is 12? So 24, right? Half of 24 is 12. So why this works is if you're thinking algebraically, what you're really saying, half times some number is going to give me an answer of 12, right? So what that means is you're going to be getting x by itself, so you're going to be dividing by 1/2 to both sides, like this. So that's really saying 12, the 2 halves will cross off on this side, and the x will be left, right? X is equal to 12 divided by 1/2. Well, 12 divided by 1/2 is what we did over here. We said 12 over 1 divided by 1/2. And this is just the same thing, 12 divided by 1/2, rewritten, writing it differently. So it's the same thing if you use algebra or if you just remember the rules and the steps. So let's clear this and let's try some problems. Actually, I don't need this on the right side here. Let's move that out. There we go. That's even bigger. Okay, so let's try 1/3 of what number is 5. So we're going to take the 5 and we're going to write it over 1 and we're going to divide it by 1/3, which we know is really the same as 5 over 1 times, flip the second fraction, 3 over 1. So it's going to be 5 times 3 on the top, 15, and it's going to be 1 on the bottom. So 15 over 1 is just going to give us 15. And if you think about it, that makes sense. So 1/3 of 15 is 5, right? So that's why that works. Let's try 7/12 down here. Let me circle that. Okay, let's try 7/12 of what number is 14? So we're going to take and I'll use a different color here. Let's take the 14 and put it over 1. Divide that by 7/12. And that is the same as taking the first fraction and keeping it the way it is, changing to multiplication, and flipping the second fraction, 12 over 7. We can cancel. 14 divided by 7 is 2. 7 divided by 7 is 1. We are left with 2 times 12 on top and 1 times 1 on the bottom. So that total answer then would be 24. Okay? So that's how those work. Clear those. I think next is word problems. Take a look. Yes, we get to apply our division skills with word problems. Now, fraction word problems can be a little bit more difficult. We know because the packet's fractions that we're going to be dividing with fractions. However, when you get mixed word problems, sometimes it's hard to decipher, am I dividing, am I multiplying, am I adding, am I subtracting, what am I doing? So let's take a look at a few problems and see how fraction word problems would look. So I'd like to do, I think number 1 would be a good one to do here. How many pieces of wood each 7.5 inches long can be cut from a board that is 45 inches long. So sometimes with word problems, I actually like to draw what it's talking about. Sometimes that helps. So here's my long piece of wood. It is 45 inches long. And how many pieces can I cut from that are each going to be 7.5 inches long? So I'm cutting, and I'm pretending that each piece is 7.5 inches long here in my little drawing. So how many of those pieces can I cut from that big piece of wood? So what I'm really saying is I'm dividing, right? I'm dividing 45, my whole piece, and I'm dividing it into 7.5 inch pieces. How many pieces am I going to be able to get out of that? Like saying I had a board that's 10 inches and I want to get 5-inch pieces. How many pieces would I get from that? 10 divided by 5, or 2 pieces, right? Same thing with fractions, it's just using fractions. So this is the same as 45 over 1, keep, change, and flip. Well, we can't flip until we change this to an improper fraction. How is that as an improper fraction? Whole number times the bottom plus the top, so it's 15 halves. We're going to flip it to make it 2 over 15. I just kind of combined 2 steps there. I hope that's okay. So now how many 15s go into 45? We said that in a previous problem that 3 went in there. 15 goes into itself once. And now we multiply across the top and across the bottom. We get 3 times 2 on top, 6. And on the bottom we get 1. So how many pieces can we get? We can get 6 pieces. So we can put that here as our answer. You can cut 6 pieces of wood. Okay. Let's try number 7. 7 is a good one. Roll down a little bit here. Maybe I can put my, oh, I didn't want that. I wanted a white box. Okay. Sarah needs 2 1/4 yards of material to make a dress for her daughter. How many dresses can she make from 10 and I think that's a half, 10 and I'll move that down a little bit, 10.5 yards of material. So it's the same thing as the lumber question, isn't it? Except now it's talking about material. So she's got this big piece of material that's 10.5 inches long, and she wants to divide that into 2 1/4 yards of material for each dress. So how many dresses can she make? 10.5 divided by 2 1/4. We have to change our improper fraction, our mixed numbers into improper fractions. So 10 times 2 is 20 plus 1, 21 halves, whole number times the bottom plus the top. I'm just going to leave it division for the moment so we don't get confused. 2 times 4 is 8 plus 1 is 9, 9/4. Now I'm going to do my keep change flip. 21 over 2 is going to stay 21 over 2. Division is going to change to multiplication, and I'm going to flip 9/4 to 4/9. 4/9. And now I'm going to cancel, because I see that some things will cancel. And they don't always cancel, but always look around for that. So 3 will go into 21. How many times? 3 times 7, right? 3 will go into 9 3 times. 2 will go into 4 twice. 2 will go into itself once. And now I'm left with 2 times 7 is 14. And 3 times 1 is 3. Don't be tricked on this one. How many dresses can she make? Well, we've got an improper fraction, so we have to divide. And we get 14 in the inside and 3 on the outside. How many 3's go into 14? 3 times 4 is 12. 14 minus 12 is 2. So 4 2/3. Now, what is the question asking us? Sarah needs 2 1/4 inches yards of material to make a dress for her daughter. How many dresses can she make? Don't get tricked on this question. Can she make 2/3 of a dress? No. So she's going to be able to make 4 whole dresses and then 2/3 of another dress, which doesn't really make sense. So you want to say your answer then is she can make 4 dresses. She'll have some material left over and she can put that away for some other use, right? So she can make 4 dresses. I'm going to write the word dresses. Okay, so when you get a problem like that, always go back to the question and ask yourself, well, what are they really asking for? Okay, let's look at number 8. I don't know why this box is still here. There it is. Okay. Number 8. On a quiz, Adriano got 7/8 of the problems correct. He had 21 problems correct. How many problems were on the test? This is one of those, what is 1/3 of some number or something? 1/3 of one of some number is this. So this is really the same as saying 7/8 is how much of 20 is equal. 7/8 of some number is equal to 21. So that's what it's actually asking. So we're saying that he got 7/8 of the problems correct. So I'm going to just write it algebraically first. 7/8 times the total number of problems equals the number he got correct, or 21. That's the same as doing what we did before in our steps. 21 over 1 divided by 7/8, which is the same as 21 over 1 times 8/7, right? 8/7. And then we just cancel where we can. 21 divided by 7 is 3. 7 divided by 7 is 1. We end up with 3 times 8 is 24 on the top, and 1 times 1 is 1 on the bottom. So how many problems were on the test? 24 problems were on the test. Of the problems of 24, he got 7/8 of them correct, so he got 21 problems correct. And that makes sense if you want to think about it. It's always good to go back and think, does the answer really make sense with the problem context? And yes, 24 should be more than 21, but 7/8 is almost all of them, so he should have gotten pretty many of those 24 correct. So that does make sense. Okay, I'm going to clear my drawings, and I'm going to let you try the rest of the packet here. And I'm going to say goodbye, and I hope you have a great day.